guys, let me introduce myself. My name is Erin Dimyati. I'm from the Faculty of Science and Technology of the Islamic State University of Raden Fatah in Palembang. Okay, right now I will explain the subject of physical chemistry about deviation from ideal behavior. Deviation from real behavior. Since depend on the practical applicability of every experiment. Theoretical, the gas law from Boyle's law to Avogadro's law seem right. But what about their practical application? Real gases generally observe the various findings of the gas law under controlled physical conditions, but also show deviation from them. Let's see how. Applicability of ideal gas equation and Boyle's law. We already know the ideal gas equation BB equal more mol time R time T. It defines the relationship between temperature, pressure, and volume of gases. For checking the reliability of this relationship, we first plot a graph between V and V. Now, we know that a constant temperature as the Boyle's law states, VB shall be a constant. Therefore, the graphs between the two V and V shall be a right straight line. But the case is not so. At temperature 273 Kelvin, the data for several gases is shown in the graph. From the graph plotted in the figure, we can easily conclude that despite the constant temperature, that real gases do not show behavior as practiced by the Boyle's law. These gases show a significant deviation from the practiced ideal behavior as per the Boyle's law. The plot in the graph signifies the deviating behavior of real gases like hydrogen, helium, carbon monoxide, and methane from the behavior of ideal gas. In fact, we see from the graph that real gases do not show anything of similar to ideal gases behavior. From our next graph that plots the volume to pressure data of gas, we find an apparent deviation from the theoretical prediction of gases in changed conditions. From the graph, we can figure out that at very high pressure, the value of volume we calculate is less than the actual practical value. Hence, from the above two graphs, it is clear that generally real gases under all conditions do not follow the ideal gas behavior or equation. The equation now is that why do gases divide from the ideal behavior? The answer lies in the basic behavior of the gases. We already know the intermolecular force between gases are minimal, duration being the scattered molecules in the gaseous stage. To the kinetic theory, molecules of gases do not have any force of attraction, and the volume of the molecules is insignificantly small when compared to the space occupied by the gases. Hence, at low temperatures, how does a gaseous matter change into the liquid stage? If there is not force of attraction, then how does the state of matter change? This negligible intermolecular force is the secret behind the deviation of real gases from the ideal gas. Molecules in the gases interact with each other. Rock in the interaction is weak at high temperature, yet will decrease temperature the interactive force increases. At, at high pressure also, these molecules come close to each other, hence leading to a decreases in volume. With increasing pressure, the interaction between these molecules increases. This interaction between the molecules prevents them from bombarding on the container. The attractive force between the molecules prevents the molecules from colliding with the walls of the container. These were the difference between ideal gases and real gases become transparent. Ideal gases are those gases which follow gas law, and the molecules of these gases have no interaction with each other, while real gases are those gases which occupy space and the molecules have a force of interaction between each other. Let's look at the pressure-volume relationship for a real gas. Now, if the temperature is high enough, real gas behave like ideal gases. That is, they have a PV float that looks like PV is a constant. As you decrease the temperature, you will encounter a point where there is an inflection in the curve. That's called the critical temperature. The critical temperature defines the relationship between ideal and real gas behavior. Above the critical temperature, gases behave like ideal gas, and below the critical temperature, they behave like real gas. So what is a real gas behavior? Let's look at a temperature. At isotherm significantly below the critical temperature. Here, we will start at a pressure and volume, and we will describe the volume, and we will get an increase in the pressure of the gas. As we continue to describe the volume, we will get to the point where we will describe the volume, but the pressure will not increase. The pressure-volume curve flat lines. You can see. So what's going on here? How do I describe volume and not increase the pressure? I cannot change the temperature. We are on an isotherm, so the only other parameter left is the number of particles. But this is fixed cylinder. How do I decrease the number of particles in the dead cylinders? Well, I cannot decrease the number of particles, but I can change their phase. I can take some particles from the gas phase to the liquid phase, where they occupy very small volume by comparison. So what happened? Its particles are moving from the gas phase to the liquid phase. As I decrease the volume change, the number of particles decrease, the pressure can stay the same. Of course. Why? I will get to a point where I will compress to such low volume that I will come even that's actual condensed liquid. And then again, it will be very difficult to compress that liquid, and I will go to that very low compressibility phase. So ideal gas, as you compress them, the compressibility decreases real gases. As you compress them below their critical temperature, will undergo a phase transition. Phase transition is the critical separating point between real and ideal gases.
Audio Jungle. 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 Audio Jungle.
Thank you for watching, and don't forget to take care of your health, each of the COVID-19 virus.
Audio Jungle.
Remember to always wash your hands every time you touch on object or person. Eat
Audio Jungle.
Eat healthy food, drink lots of water, and don't forget to pray. And don't forget to like, share, comment, and subscribe. And thank you guys. Wassalamualaikum warahmatullahi wabarakatuh.